Okay, let's look at exercise 3.4 now. So for question A, we are given this straight line. So we are asked to find the domain and range for this line. So in order to answer this question, what we need to do is to take a point on the line and then drop it to the x-axis. Drop it like this. Okay? So since this line will continue until infinity, therefore we will see that all this value of x will move towards infinity. So the same goes for the point on the right hand side. When we take a point here and then draw the dotted lines towards the x-axis, we actually can continue doing this because the line will can be prolonged until infinity. Therefore, the value of x will move towards infinity. Okay? So, hence we can say the domain will be all the values of x which exist. So, we will write as all values of x where x is a member of R. So, if you look at the range will refer to points where we actually drop it to the y-axis. If you look at the green lines, so if you take a point here, drop to y-axis, take a point here, drop to y-axis, and since this line will continue, the value of y will also continue until infinity. So the same goes for a point here, drop to y-axis, and we can drop another point here, and we can continue doing so until the value of y approaching infinity. So therefore we can say the value of y can be any value here as long as it is a member of the real numbers. Okay? Next example. So if you are given this curve, so same thing, you can take a point from the curve, drop it to the x-axis, continue doing so, until the end of the curve. Since the end of the curve is infinity, therefore we can say the value of x is moving towards infinity. The same goes for right hand side, so the value of x will move towards infinity. Hence, we can say domain equals to any value of x, as long as it is a member of R, that is the real numbers. So what about the range? So the range refers to points which we drop to the y-axis from the curve. So if we drop to the y-axis, and since this curve can be prolonged until infinity, therefore we have the value of y moving towards infinity here, downwards. But at the top we have y equals to n. So beyond, after y equals to n, we cannot drop any points from the curve. So in other words, this is the limit of the range. So therefore we say the range of this curve is equal to all values of y, where y must be a member of R, and then y is limited by n, which is smaller or equals. So we write y less or equals to n. It must be below y equals to